So we'll discuss the properties of the wave starting with the reflection. There are different properties of the waves. A reflection is one of them. Then there's a refraction, diffraction, interference, polarization. But polarization is only specific for the electromagnetic waves. It's not for the mechanical waves. Only electromagnetic waves, the polarization happen or occur. So, like it's a characteristic property of the transverse waves. Now, first, starting with the reflection, how we define the term reflection? Reflection is a property of a wave to change the direction when it strikes the surface. So, when the wave changes the direction after striking a surface, we call that as a reflection. And we can explain the reflection by using either the wave fronts or the wave. But it is convenient to use a wave front rather than the wave to show the reflection. Like if these are the wave fronts, what is the direction of the wave? The direction of the wave is always perpendicular or 90-degree to the direction of the wave front. So if these are the wave front, what will be the direction of the wave? So the direction of wave will be like this. When the wave strike the surface, it changes the direction after striking a surface. So when it changes the direction after striking a surface, we call this as a reflection. This is reflection in terms of the wave fronts. But if you want to explain the reflection in terms of the wave, you have to remember two things. Whenever a wave undergo a reflection, when it strike a low density medium to a high density medium, it will undergo a phase change of 180 degrees. Means the angle of the wave changes by 180. What does it mean? For example, this is air and this is representing a glass. So when the light waves strike the air to glass boundary, say the waves strike, the crest strike the surface. So if the crest strike the surface, what will happen? What will the reflected pattern? So then the reflected wave will start with the trough. So if the crest strike the surface, the reflected wave will start with a trough. So what does it mean? It means the wave have undergo a phase change of 180 degrees. Because like first the crest strike the surface, but when the wave started, it started with a trough. So what is the phase difference between these two waves? Between these two waves, the phase difference is 180 degree. This only happens if the wave strike the low density to the high density medium. But if the reflection happen or occur in opposite way, like example, a wave strike a high density medium to a low density medium, in that case, it will not undergo a phase change. It will reflect, but there is no phase change in that case. So, say a wave is there in a glass and it strike the air. So when waves strike the glass to air boundary and the reflection happen or occur, so if the trough strike, then what will be the reflected wavefront? It will start with a trough. Or if the crest strike, if the crest strike the boundary, what is the reflected wavefront? It will also be a crest. So whenever a reflection happen or occur, reflection means the property of a wave to change direction when it strike the medium. In terms of the wave, it may undergo a phase change. When it will undergo a phase change? When it strike a rare to denser boundary. But if it strike denser to rarer boundary, there is no phase change. Is it clear? The concept of the reflection? Anyone having a doubt or a question till this point? So as a wave strike, like example, strike a boundary, so, and it changes the direction, what we call that as a reflection. And if it strike a low density to a high density medium, it will undergo a phase change. So if I say the wave which strike is like this, if I want a wave which is bounce back, so what will the wave which bounce back? So it will start with a trough and ending at crest. What does it mean? It means it undergo a phase change of 180 degrees. The second property is a refraction. Refraction means the property of a wave to change speed. When the wave changes speed as it travels from one medium to another, we call that as refraction. So in a refraction, the direction also changes, but it is not always true that the direction changes. Some scenarios, some cases, the direction in which the wave travel, the incident and the refracted, the direction does not change. So that's why if you say a refraction is also a change in direction, that is not the right definition. It should always be refers to speed. So when the wave travels from one medium to another, it changes the speed and we call that as refraction. Different types of waves we can observe, like example, if you're observing a light waves and a light is there traveling in air or a vacuum and it moves into the glass. What will happen to the speed of the light? Will it increase or decrease? Which medium the light travel fast? Is it air or a glass? Which medium the light travel fast? So in air, the light travels faster and in glass, it travels slower. So when the light travel from air to glass, the speed of the light change, it might, in this case, it will decrease. So what we call this phenomena, which this property of a wave, we call that as refraction. Same way, when we talk about sound, the sound, say the sound is traveling in air and it moves into a liquid, a gas to liquid. Which medium sound travel faster? Is in air or a glass, in a liquid? In which medium the sound is having a higher speed? Sound. Sound require a medium. Sound is a mechanical wave. So in liquid, the sound travels fast and in air, the sound travels slow. Because if you recall the idea of the speed of a sound, the sound is traveling faster in solid, which is speed is about 5,000 to 6,000 meters per second. Where in liquid, it's about range of a 1,500. And in gas or in air, it's about 330 or 340. So the sound travels slower in air and it travels faster in liquid. So when the sound travels from air to liquid, what will happen? The speed of the sound will decrease. So here the speed of a sound will increase. Here the speed was decreasing for the light, but for sound it is increasing. So this property of a wave to change the speed, what we call that as refraction. We call that refraction. Same way we can also consider a water wave. When the water waves travel from one medium to another, how the medium will change for the water waves? How the medium will change for the water waves, because in like we have two regions of the water, we have a deep water and we have a shallow. Which medium the water travel faster? Is it deep or a shallow? In which medium the speed of a water is greater, the water waves? Deep or shallow? So you have studied in this IGCSE that water travel faster in deep and it travels slower in shallow. So speed of a water waves, water waves travel much faster in deep region, but in a shallow water, it decreases, reduces the speed. So when a water changes a medium, changes a depth, the water wave changes a depth or the medium, what we call this property as refraction. So in this case, the speed will also decrease. So the change in the speed as the wave travels from one medium to another is known as refraction. And whenever a refraction happens, the rule is that the frequency never changes. Because if the frequency changes, the whole wave will change. Frequency is the identity of the wave which cannot be changed. So frequency never changes. Frequency always remain constant. So how the frequency remain constant? We have the formula that V is equals to F lambda. The frequency is actually a ratio between the speed and the wavelength. So in case of a light, like if a light is traveling from air to glass, the frequency should be constant. So frequency is a ratio between the speed and the wavelength. So when the light travels from air to glass, it slows down. So if the speed of the light will decrease, the wavelength will also decrease, but the ratio of the speed and the wavelength will remain unchanged. Same thing, when a sound is traveling from air to liquid, it gets faster. So speed is frequency divided, frequency is speed divided by wavelength. So as the speed of the wave increases, the wavelength should also increase, but the ratio of the two should remain unchanged. And moving from deep to shallow, as the speed is decreasing, so the wavelength should also decrease so that the frequency remain unchanged. So the frequency, which is a ratio between speed and wavelength, that ratio remain unchanged. If the speed increases, the wavelength will also increase. If the speed decrease, the wavelength will also decrease. But the ratio of the two in every medium will remain unchanged. So refraction is a property of a wave to change the speed when it travels from one medium to another. Is it clear? The concept of refraction, the property refraction? Any doubt in this? Anyone having a question or doubt in a refraction? So refraction, the property of a wave to change speed when travel from one medium to another. For example, if you're observing the water waves in a ripple tank means a large container which is filled with water, and we are observing from the top. So in a deep, the waves are traveling faster, but in a shallow, the waves slow down. So here the waves are traveling fast, here the waves are traveling slow. The frequency, which is a ratio between speed and wavelength, and here also the frequency, which is also a ratio between speed and wavelength. So in a deep, it is traveling faster. Like example, let's take an example, say speed was 10 meter per second. And the wavelength means the distance between the two successive crests or the two successive wave fronts. Let's take that this was 5 meters. So if I want find a frequency, which is a ratio between the speed and the wavelength, so speed is 10 and the wavelength is 5, so I'll get the frequency as 2 hertz. When it move into a shallow region, the speed decreases, so as the wavelength. As you can see, the spacing also it decreases. So we have the formula, the frequency is speed divided by wavelength. So the speed decreases, like example, speed might become 2 meter per second. And the wavelength, the spacing between the two successive wavefront, example is 1 meter. So speed is 2 and the wavelength is 1. So when we divide, again we get 2 hertz. So the frequency of the wave never changes. The frequency remain unchanged. Is it clear? The concept of the refraction. Anyone having a doubt? So property of the wave to change the deep water is considered. Yes, deep water is having a low density as compared to that of a shallow water. But in a refraction, when a refraction happens, the wave sometimes changes the direction as well. So the change in but the definition of refraction does not involve the change in direction. But sometimes what happens when the wave travels from one medium to another, it also changes the direction. Say this is a boundary between the two mediums. And if the wave is moving perpendicular 90 degree to the surface, and it undergo a refraction, in that case, what will happen? The only difference, it will only change the wavelength and the speed. So when the wave direction of the wave is perpendicular to the direction of the surface it strike, the only thing what will happen is there will be a change in speed and the wavelength, but no direction change. But if the wave is having certain angle, like striking the medium or the surface, like example, let's take an example of the water waves. These are the water waves. So this is a deep region and this one is a shallow region. Now, when the wave strikes at a certain angle, now in this case, the wave will also undergo a change in direction. These are the wave fronts. So what will happen, because let's take example of the water wave. So this is a deep region and this is a shallow region. So in a deep, it's travel much faster as compared to that in a shallow region. So if it was traveling at the same speed, then should be the position of the wavefront. Because if it is moving at the same speed, then this should be the direction of the wavefront. But because it is traveling slower in a shallow region, so the wavefront will lag behind. So this will be the direction or the position of the wavefront in a shallow. So as you can see, the direction has changed. Like this was the original direction, but now what is the direction? This is a new direction. So there is a change in the direction. When the direction of the wave changes, when it changes the medium, a refraction happen. So this is also a refraction, but when a wave strike at an angle or a certain angle to the surface, then only it will undergo a change in direction. But if it is striking 90 degree or perpendicular, if it strike 90 degree or perpendicular, in that case, there is no change in direction. It's only a change in speed and the wavelength. Is it clear, this one? So angle, in this case, the angle will decrease. Angle with the normal will decrease. So the same idea, like when the speed decreases, in a deep it was traveling faster, in a shallow it was traveling slower. So if the speed will decrease, the angle will also decrease. If the speed increases, the angle will also increase. So as it wave is moving from a deep to shallow, the angle in this case will also decrease. Angle from the normal. Normal is a perpendicular to the surface. If we draw a normal here, we find that the angle from the normal will decrease. The next is a diffraction. Diffraction means the property of the wave to spread out when it is passing from one medium, from passing through the gap or near the edges. So when the wave move from one medium to another, like passes through the gap, it changes the direction and spread out. We call that as a diffraction. So and diffraction can happen when the wave is passing through the gaps or it is passing near the edge. So first, for a diffraction to happen or occur, the maximum diffraction happen or occur when the wavelength is approximately equals to the gap size. When this gap size and the wavelength are approximately equal, then we observe a maximum diffraction, means maximum spreading of the wave. And how we represent, like example, if this is a direction in which the wave travel, if the gap size and the wavelength are equal, the wave will spread out maximum. There's also a formula to relate the diffraction and the gap size, but that is later in the light you will learn, because right now we are just discussing the general properties of the wave. We are not specifically learning like the diffraction of a light, diffraction of a sound, but general properties of the wave. So diffraction, what is the concept of the diffraction? Diffraction means spreading of the wave when it passes through a gap. So when the diffraction is maximum, when this gap size is equal to approximately equals to the wavelength. In that case, the wave will spread out maximum. But if the gap size is larger than the wavelength, so this is a gap size, the width of the gap, and this is representing the wavelength. So the wavelength is smaller and the gap size is larger. So in that case, diffraction will occur, but a very small diffraction. How we represent that in terms of the wavefront? So we use a plane wavefront. Plane wavefront means straight lines, and just near the edge we'll make them bend. So this means diffraction happen or occur, but it is a small diffraction. When we draw the curve wavefronts, it shows that the waves spread out in all the directions. What we call that as a maximum diffraction. So diffraction to occur or happen, the gap size should be equals to the wavelength. Now diffraction about near the edges, what factors it depends on? So diffraction is basically the spreading of the wave when it passes through a gap or edges. And if we have a longer wavelength, near the edges, it will diffract more. Like, say we have, these are the edges, and we have two wavelengths. One is a longer wavelength means like large space between the successive wavefronts. And we have a shorter wavelength. So what is the observed phenomena that when these wavefronts are passing near the gap, it changes the direction. But which wavefront changes the direction more? It is observed that the longer wavelength, the wavelength which are having a, like the wave which is having a longer wavelength, it's spread out or diffract more. But the shorter wavelength, when it passes through the gap or near the edge, it will diffract, but a smaller proportion of the wave will diffract. So that's why for communication, what we prefer, like example, if we want to communicate, we use a radio waves. Why we prefer to use a radio wave? Like in case of an obstacle, like buildings are there. So when we use a radio waves have longer wavelength. So for a communication, if we use a radio waves, as the radio waves having a longer wavelength, so it's spread out more. But if we use the higher frequency or the shorter wavelength, such as ultraviolet we are using, so in that case, the UV rays which are having a shorter wavelength, so it passes through the gap near the edge, but it will diffract less. So it won't reach this region. So diffraction means the property of a wave to spread out when it passes through a gap or near the edges. And diffraction to be maximum, the general rule is that diffraction to be maximum, the gap size must be equals to the wavelength. And if we have edges, then the longer wavelengths diffract more than the shorter wavelengths. Is it clear? Like this is just a calculation explanation of the diffraction. Say speed of a sound in air is 330. The typical frequency of a sound, it vary from person to person as we sound different to each other. That because of our pitch or the frequency, the number of waves we produce every second. So the typical frequency is like 440 hertz, which we produce a sound. So if we work out the wavelength, the speed is wavelength times the frequency. So wavelength is speed over frequency. Now 330 divided by 440. So what is the wavelength of a wave which we produce? That is 0.75 meters. And if you compare the door size, the gap, the opening of the door, what you find, it is also in the same order. Even the house is big or small, but there is a standard door size is used, like the width of the door. What is the reason for that? The reason is that like this gap is around like 1 meter or smaller. So what is the purpose of using this? So what will happen, like if this is a top view, here is a door. So if a person is there, like standing at position A and he's calling a person at position B. So a typical wavelength is 0.75 meters. And this wavelength matches with a door gap. So as a result, the wave will diffract more, spread more. So means that if A is not able to see B, but A can hear B because of diffraction. So due to the diffraction of the wave, we are able to record, like receive the radiation even though we are not in the line. Is it clear? This concept of diffraction of a sound wave example? Any doubt in this? Even diffraction happen for the light as well. Like example, if this is representing a laser which strike the screen, if we place a object or a slit which is having, if you place an object or a slit which is having the wavelength of a wave is same as the gap of the slit, then we observe a diffraction. But this diffraction, like this spreading depends on the slit. Like example, if the slit is vertical, if slit is like this on the screen, what we will observe? If slit is vertical on the screen, how we'll observe the pattern? The pattern of a diffraction, we'll observe a pattern of a diffraction spreading in the horizontal plane like this. But if the slit is horizontal, if this slit is horizontal like this, how we'll observe the diffraction pattern on the screen? So remember, because this is a spreading. So if the split is, so in that case, we'll observe the vertical scattering. Like the pattern will be like this. So always remember when a diffraction, because it is passing through the gap, when the wave is passing through the gap, it's spread out. What if we have a circle? Means a small opening is there. So what will the diffraction pattern we'll observe? Because it's just, if you draw the directions, the wave will spread out in all the directions. So on the screen, what will the diffraction pattern we'll observe? So we'll observe a diffraction pattern as a circle. So these are different diffraction pattern depending on the position, how the slit is placed. Slit might be placed horizontal, slit might be placed vertical. Or it might be a small opening. So spreading of the wave when it is passing through a gap, what we call diffraction. So for this is a just example of using the radio waves for communication. Like as a tower is producing the waves, these radio waves are there. And here is an antenna. which is placed on the top of the house, then that house is located in surrounded by a tall buildings or the mountains. So what will happen if you use a longer wavelength? It will diffract more. So as a result, the antenna can pick up the signal. But if we use the shorter wavelength, which will diffract less, so we will not be able to receive those signals. So which you have a difficulty with the signal strength on your short wave radio. So which one helpful words and phrases to use? You have long wavelength, short wavelength, diffract, gap, edge. Copy and complete the diagram and illustrate your answer. What I will say here, which waves are used, long or short? So what I will use, which wavelengths are used here? So this will be a short wave. It will diffract, but it will diffract less when passing near the edges. But the long wavelength, when I'm using a longer wavelength, it will diffract more. So as it diffract more, it will be easy to record. So long wavelengths can diffract more as it passes near the edge as compared to the short wavelengths. So what A is representing? Which of the following shows how the rays are? What A is representing? Is it a reflected, diffracted at a gap, diffracted at an edge, or refracted? So what A is representing? A is representing it is a diffracted through a gap. What B is representing? What B is representing? B is representing the refracted. What C is representing? C is representing it is reflected. And the last one, diffracted at the edge. So D is representing the diffraction at the edge. So these are some properties of the general properties of the waves. So what A is representing here? A is representing refraction. What B is representing? B is representing reflection. What C is representing? C is representing diffraction at the edge, and D is representing diffraction at the gap. Now, electromagnetic waves. What are electromagnetic waves? Electromagnetic waves means the wave which can travel through vacuum does not require a medium. We call them as electromagnetic wave. For the electromagnetic wave, you have to, in A levels, you have to learn the range of the frequency and the wavelength. Yes, you have to memorize the wavelength and the frequency for all the electromagnetic waves. So radio waves, which are having the longest wavelength, this is like range is given. Some books, the range is like it's greater than 10 power 6, but usually in this order, 10 raised to power 3 to 10 raised to power 0 is a wavelength range, and the frequency range is also given. You have to memorize, you have to learn this. So what happened in the electromagnetic radiations as we move from radio to gamma? What we observe the frequency increases, and we observe the wavelength will decrease. And so as we move from radio to gamma, this is a pattern of the wavelength as well as the frequency we observe. So radio waves we use for communication, microwaves we use for satellite communication. Like if we want a land communication, we use radio waves. But But if you want a sky communication using a satellites, we use a microwaves. Infrareds are used in the intruder alarm as well as the remote controls or Bluetooth devices can also use. Then visible lights, it is to observe. If you want to observe, we use a visible light, which include the violet, indigo, blue, green, yellow, orange, and red. Red is having the longest wavelength and violet is having the shortest wavelength. Then we have the ultraviolet. Ultraviolet is used for to kill bacteria or sterilizing. It can be used. Then X-rays are there for a medical imaging or a security check we use. And the gamma for the treatment of the cancer. We we use the gamma radiations. You have to, what is the mistake here in this? This is 3 into 10 power 8, not 8 into 10 power 8. This is 3 into 10 power 8 meter per second. That is the speed of all electromagnetic radiations. You have to learn these orders for frequency as well as the wavelength. Now, what is actually an electromagnetic wave? Photons, we'll discuss later in the topic light. Light is having a dual nature. It can be a particle or a wave. So photons are called the particles of the light, the packets of the light. When we say it's electromagnetic radiation, so you should be able to draw as well. How you will draw electromagnetic radiation? The term electromagnetic radiation means it has electric and magnetic fields. So, and both are perpendicular to each other. Say this is electric field, vibrating electric field. Then we have a magnetic field as well. Both are 90-degree. I try to draw the 3D structure. So blue one is representing the magnetic field. So electric field and the magnetic fields are 90-degree to each other. Like the example, if this is representing the electric field,